So in this case, we are going to consider a typical exam revision. This is a Free State province that we are going to have for our grade 11 mathematics. We had the previous one, which was test 4. Now we have got test 5 that we're going to consider. But all these, they were just informal tests, okay? Just to test the students, all right? So that is why you see, guys, Free State is having this high pass rate. These tests all over. So, guys, if you've got a test that we can consider from your province, you can send that so that we can work on that to assist also others in the revision and also you at the same time. So this is just a quick test that we are going to consider. So as we are given, make sure that you go through the instructions and information. So this question paper consists of 2 questions, guys. It was just a short test. This is February, not March, okay? So definitely, guys, go through, okay? Everything. If necessary, round off your answers to 2 decimal places, unless stated otherwise. So that was what we had. And quickly looking into the questions that we were given. Question number 1, solve for x in each of the following. So the first part here, it was to solve for x. Okay, so let's see, guys, our equations, and also there is an inequality. So, okay, let's see. First part, that is an equation, 1.11. So for x, given 2x squared minus 7x is equal to 0. So how can I solve this type of equation? It's a quadratic, and we are given 2 terms. That's dealing with a binomial. So factorization is the best, guys. 2 terms. Just consider factoring out the highest common factor between the 2 terms that we have. So between 2 and 7, we have a common factor there. We do not have 2 is a prime number, 7 is a prime number. So we do not have any number that can be used in between these 2. All right. So we move on to x squared and x. So we can see that x is the highest common factor, the one with the smallest exponent. So that is the one that you factor out. So with this, what are you going to have, guys? Divide 2x squared divided by 2x, by x, sorry, that will be 2x, like this, 2x squared over x. So this one into this one, it's going to remain with 1. Remember, there are 2 of them, just like x times x. So if you cancel, you'll remain with 1. Okay, minus 7x divided by x, that will be minus 7. Okay, take note, minus 7x over x, this will cancel. So you remain with what? Minus 7. That is equal to 0. So with these 2, the product, remember the 0 concept, guys. Once you see this 0 here, the concept, the product of 2 terms to give you that 0 that you see there, it is either one of these 2 must be equal to 0. So it is either our x is equal to 0 or this bracket of 2x minus 7 must be equal to 0. So this one already we have solved for x. So we move to this one, we solve for x. How can we solve this? It is now a linear equation, this one. This is a linear equation. So to remove this minus 7, we are going to add 7 both sides. So that is 2x. Remember, this cancels, is equal to 0 plus 7, which is 7. That's a product. So simply divide by what? By 2 both sides. So this was going to cancel. X is equal to 7 over 2. So you can leave it like that. As 7 over 2. You can have it as a fraction, right? You can have it like as a mixed fraction, 2.5. You can have it as a decimal. It is up to you in terms of the simplification or in terms of how you are going to solve your equation in that case. So make sure that, guys, you do revise your equations, all right? So if you check, 2x cannot be said here is the highest common. You cannot factor out 2. X is the highest common factor there. All right. So that is it, guys, on our question. We move on to the other part. And also, let's say you wanted to use the quadratic formula. Is it possible? All right. Is it possible? Another way, maybe you're given this. Most of us, guys, most of you, you're just used every time you see an equation, a quadratic equation, you always think of the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, which is fine. But you must know your a, b, c, and d from the quadratic equation. Ax squared plus bx plus c is equal to 0. So that's we've got a, b, and c. So in our case, we can see that we have this 2x squared minus 7x, but we do not have the part of c. So it is just like this, guys. What it simply means, it is just like 2x squared minus 7x. We do not have the constant. So it is just like we've got what? A 0 like that. That is what it means. The constant, the c, that's a 0 there. So meaning to say, if you are to use your quadratic formula as you are to substitute into this formula, x is equal to minus, all right, our b there, that's the coefficient of what? X. So that is what? Negative 7. Plus or minus the square root of b squared, which is the same minus 7 that we had. So that's minus 7 squared minus 4 times a, the coefficient of what? X squared. So that is 2. And our constant c, which was not given. So that means the number there is what? Is 0. There's nothing there. All right. So that is 2 times a, which is 2 times 2. Just like that. So you can simply use your calculator, guys, to simplify. Like as I always say that it is best that you indicate what is under the square root first before we consider the simplification of the whole part. What is under the square root? Only this part, all right? So that is negative 7 in bracket squared minus, guys, we are multiplying by 0 there. So meaning to say everything is going to give us a 0, but we can simply multiply 4 times 2 times a 0, no problem. That was going to give us what? 49. So this is what we have. So minus, minus, that's a positive, all right? Plus or minus the square root of what? Of 49. Remember, we got a 49 there. Everything over what? 2 times 2, which is 4. So just like that. So from this, guys, we can simply use our calculator to simplify this part. So that was going to be, okay, we put the fraction. That's let's start with the plus here. Sorry for that. We're going to start with the plus. So that is it. 7 plus the square root of 49, everything over 4 like this. So that was going to give us what? 7 over 2. So this is 7 over 2. Or we move on to the other part. We determine the x when we have the negative. So we're just going to change our positive here into a negative. So that was going to give us a 0. So as you can see, guys, these are the same answers, the ones that we obtained as we worked our question using the factorization, working with the factorization. But if you understand even your quadratic formula, you can still use that. But the first part of your quadratic equation, guys, just try to use your factorization. All right. Anyways, this is exam, guys. You use what you understand. On another part, you're given to solve this, leave your answer correct to 2 decimal places. That's where you can use your quadratic formula. When they give you an instruction like this, they know that you're not having factors. You do not have factors. So you can use your quadratic formula. You can use the completing of the square method, any part. All right. So you're going to take our equation that is given. That's 1.12, which is 2x into the bracket of x minus 3. That's equal to 1. So as we can see, with the bracket that we are given, we need to expand this part, get rid of the brackets, and see the type of equation that you're going to have. So 2x times x, right? That was going to be 2x squared. Remember, you distribute inside the bracket. 2x times negative 3, that's negative 6x, right? Which is equal to 1. But as we have the highest power being 2, that's a quadratic equation. So the format, guys, ax squared plus bx plus c is equal to 0. You're supposed to have what? The format. One of the side must be equal to 0. So you're supposed to take the 1 to the other side. So it was going to be 2x squared minus 6x minus 1 is equal to 0, like this. So using our quadratic formula, I already wrote the formula before, guys. X is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a from the minus b up to the end, like that. So this is it. The coefficient of x squared, that's our a. The coefficient of what? X squared. So our a in this case is 2. The coefficient of x is our b. What is the coefficient of x? That is what? Negative 6. So our b is negative 6. C is the constant, which in this case is what? Negative 1. So that means x is equal to minus b. Our b is what? Negative 6. So you're going to have plus or minus the square root of b squared, the same b, which is minus 6 squared minus 4 times a. Okay, that's 4ac there. So that's our a, which is 2, and our c, which is negative 1. All right, everything over what? 2 times a, which is 2 times 2. So just like the previous case, it is important, guys, just to simplify what is under the square root there. So you're going to have minus minus, which is positive 6, plus or minus the square root of this part under the square root. Just try to see the number there that you have under the square root, even for the examiner. And that is going to, the marker actually, it needs to see that number, guys. Just try to simplify that part. All right, so that is, we've got negative 6 squared, open a bracket, minus 4 times 2 times negative 1. All right, as it is here. So that was going to give us what? 44. So this is 44, everything over 2 times 2, which is 4. So that is it. From this, separating of this part is not even important. We can just write our answers from there. But here, just trying to indicate the number that is under the square root that we are having there is important, guys. So that is it. So to 2 decimal places, remember. So that is, let's say for our fraction 6, we're going to start with a plus. All right, so we need a fraction, sorry. So that's 6 plus the square root of 44, everything over 4. So with this is what you're going to have. And to 2 decimal places, that's 3.16, or you can just fix your calculator here to 2 decimal places. All right, so that's 3.16. It's 3.16, or our other value of x from here. Let's just change this into a negative. All right, sorry for that. This was too fast. So changing this into a negative, it was going to be negative 0.16. Already, I have fixed the calculator to 2 decimal places, just like that. So you can use your quadratic formula. You can also use the completing of the square. So I want to challenge you guys to use completing of the square method to prove if we are going to have the same answers. We talked about this, guys, using of the completing of the square method as a topic. So make sure that you go through that. Try to figure out how these questions are being given. All right, so considering 1.13, let us solve this 5 marks. All right, let us just try to have some space here. There's a lot of things here. So that's 1.13 we are given. It was the square root of 1 plus x, okay, which is, okay, plus 5. There was a plus 5 there, and this is equal to x. All right, so with this, guys, we can consider that there is a square root. So we are dealing, or we are working with the sets. These are equations which are under sets, where, guys, I said you must make sure that the said here is on its own. You must make it the subject. Consider it on its own before you square both sides, before you square. So we must make this one the subject. So what is affecting? We must remove everything that is on the left-hand side, which is affecting this square root, okay? So anything which is not part of the square root, like this 5 that we see here. So we can get rid of the 5 first, subtract it, or just take it to the other side. The moment it crosses the equal sign, it becomes what? A negative, or we are just subtracting what? 5 both sides. So we are going to remain with what? The square root, remember? That's the square root there of 1 plus x, which is equal to x minus 5. Now that we have got a single square root, a single said on its own like this, we can now get rid of that square root by what? Squaring both sides. All right, so you square both sides. Remember, it's an equation. Whatever that you do on the left-hand side must be done on the other side. So by squaring, we are simply removing this square root. So meaning to say we are going to remain with what? 1 plus x, which is equal to this. So we can square that from your expansion of brackets, guys. There's x minus 5, another part again, x minus 5, 2 brackets. Or you can use your identities, guys. Remember, I talked about this a squared, a minus b squared. The square of a bracket like that, when you're given 2 terms, a binomial, is equivalent a squared minus 2ab plus b squared if we have got a negative there. What is important is that you know the first term, that you have got the first term and you have the last term, which is b. So in our case, our first term here is what? X. Our last term is what? Is 5. So if you know these identities, it becomes easier because you know that it's going to be what? A squared, which is representing what? X. This is our A, this is our B. So when you are saying A squared, it means we are going to have what? X squared. Minus 2AB, it means minus 2 times A. Our A is what? It's X. Our B is what? It's 5. So you multiply minus 2 times X times 5. So that's negative 10x, all right? So it's going to be negative 10x. Then the last part, it's plus b squared plus the last squared, the last term squared. Our b is what? 5. So 5 squared gives us 25. So just like that. Or you could have expanded, just like I was saying, 2 brackets, x minus 5. So you have 1 bracket here, another bracket here using the FOIL method. X times x, which is x squared, x times this minus 5x, minus 5 times x, minus 5x, minus 5 and minus 5, plus 25. You collect your like terms. So you're going to have something like this. So guys, this is mathematics. You are not limited, guys. You are not limited in exam. All right? Once you have the highest power 2, you're back to the quadratic equation, guys. We are back again to that quadratic. Our quadratic equation, what is the format? Once we see the square, one of the sides must be equal to 0. That is what we know, one side. So we can take these terms to the other side of the equation so that one side becomes what? Becomes 0. So that's 0 is equal to x squared minus 10x. So this x to this side will be what? A negative the moment it crosses the equal sign. Remember, it was a positive, so it becomes what? A negative. All right. Plus 25. We take the 1 to the other side. It was a positive. The moment it crosses the equal sign, it becomes what? A negative. So that is the case. So 0 is equal to x squared minus 10 minus 1 here. That's minus 11x. 25 minus 1, that's 24. So this is what we have. As we do understand that the if A is equal to B, it simply means that B is equal to A. So if I write this is equal to 0, it's still the same as what I'm having here originally. So I can choose to start with my algebraic part here, minus 11x plus 24, that's equal to what? To 0, like that. So we can solve this equation. Figuring out, is factorization possible before we consider what? Before we consider the use of the quadratic formula. It's not always where the quadratic formula, guys, is to be used. Yes, in other cases where we see that factorization there is limited, it cannot be used. But let's try factorization because the coefficient here of x is 1. That's why, guys, if the coefficient is 2, 3, in that case, I will just advise you guys to use your quadratic formula. But when it is 1 like this, guys, just try, because you need what? Factors of what? 24, which add up to negative 11 products, two terms that you multiply. But when you multiply these two terms, you must get what? Negative 24. Add those two terms, you must get negative 11. So 24, there's something about 24 and 11 between 8 and 3. But how can we get positive 24 and negative 11 by adding? So it must be negative, negative here. If you multiply these two, you get positive 24. If you add these two, you get what? Negative 11. So these are the two numbers, minus 8 and what? Minus 3. So guys, you see factorization was going to work. X minus 8, x minus 3 is equal to 0. So we know that just like I explained before from the 0 concept, one of the brackets must be equal to 0. So x was going to be what? Minus 8 to the other side was going to be positive 8, or x is equal to minus 3 to the other side was going to be what? A positive 3. Just like that. So this is what you were going to have by using your factorization. So I want you to use the quadratic formula and prove you're going to have what? The same answers. But remember, this is a SEDS. We must compare the values of x that we obtained if they do satisfy the equation that were given before. Originally, for the values of x that we have determined here, we can substitute and prove to see, not to prove, but to test, to see which value of these two is the exact one, the one that satisfies your equation. So when x is 8, put x here in place of what? In place of x, and see if the left-hand side is going to be equal to the right-hand side. So that's the square root of 1 plus x. Our x is what? 8. 1 plus 8 plus 5, which is outside of the square root. When we add this, we must get x, and our x that we are working with what? Is 8. So let's see. 1 plus 8, that's 9. Square root of 9, which is 3. Then we add 3 plus 5, that's 8. 8 is equal to 8. So as you can see, guys, with this value of x, which is 8, the left-hand side becomes the same as the right-hand side. So this is the exact value of x that we want. What about when x is 3? Let's test. In place of x, we're going to put what? A 3. Where x was in our equation, we are going to put what? A 3, and see. 1 plus 3, that is 4. And the square root of 4 is 2. 2 plus 5, that's a 7. Is 7 equal to 3? No, this cannot be equal. 7 is not equal to 3. So x cannot be equal to what? X cannot be equal to 3. It is because the left-hand side and the right-hand side, they are not equal. So in our case, our x was going to be what? 8. This is the value which can make the left-hand side and the right-hand side to be equal. That is the case. Just like that. So you see, guys, they just want to test you. They're just testing you, the basics. But these are nice questions just for basic informal test. These are nice questions to work with, guys. I don't want to lie. They are nice questions to test where you are exactly. 1.1 form, inequality. X minus 3 into x, okay? This is x minus 3 on its own, and this is 2 minus x. All right, that's greater than 0. So this is it. We are given a quadratic inequality. Why so? Because they've got two brackets. So if we had to find the critical values, you're going to have two values. So that's a quadratic inequality. Remember your quadratic inequalities, guys, you're going to need what? Critical values. So from here, guys, already we've got brackets here. Let's find our critical values from there. Remember, the critical values are the conditions where we equate the brackets to 0, where we take x minus 3 to be equal to 0. Or x, this one, 2 minus x to be equal to what? 0. So what will be the values of x? Minus 3 to the other side will be a positive. So x is equal to 3. Or minus x to the other side will give us what? Positive x. So x is equal to what? X is equal to 2. Remember, these are critical values, not the solutions to the inequality. No, they are just critical values, the ones that will help us to determine the exact value of the inequality, depending with the method that you're going to use. Are you going to use the number line? Are you going to use the graphical method? Guys, I explained both methods, so you choose the one that you want. Using the graphical method, how can we not? Because the graphical method, we must have a curve either this way or this way, which is determined by the value of a from ax squared plus bx plus c, remember. So in our case, we cannot see this quadratic because of what? The brackets. So are we supposed to expand everything so that we properly see that quadratic? Yes, you can do that. Or you can simply multiply. You know that x is going to expand here. It multiplies here. The same thing, minus 3 here. Where is it that we have x and x? We can see it is here, x to this x. So when you multiply x to this x, what are you going to have? It's minus x, this one. So you're going to obtain what? Minus x squared. That is what is important, guys. Remember, the shape is taken from the coefficient of x squared. If x squared, the coefficient of x squared is a positive, what are we going to have? We are going to have what? A smiley shape like that. If it is negative, the coefficient of x squared, we are going to have what? A sad shape. That is what is important. The coefficient of x squared, there is no need for you to expand everything there, guys. Know your graphs. Know your inequalities. So that is the case. So using the graphical method, we can see that the coefficient of x squared is negative. Our a is -1. So we are supposed to expect a shape like this, which is a sad shape because of what? The negative that we are seeing there. So this is what we are going to have in the negative. This is your a being negative is going to be like this, all right? So this is our x-axis, all right? So just like that, guys. So with the values of x, the other one is 3, the other one is 2. So 2 will be this side, 3 on the other side, all right? So let's say this is 2, this is 3, just like that. This is your shape. Yes, you can expand your brackets. I'm not saying it's wrong. You can expand, guys. Still, you see that you have it what? At negative. So where is it that this f of x, which are these two brackets, they are what? Greater than 0, because you're saying this is our f of x, the two brackets. They represent f of x. F of x is what? Greater than 0. Where is it that our function here is greater than 0? That's above what? Above the x-axis. We are now back to our functions. So it is above x-axis. And I said when it is above the x-axis like this, bounded by a curve, and the x, whenever it is bounded like this, your solutions will be that x will be greater than the lower value, which is 2, all right, or less than the bigger value, which is 3. So x is greater than 2, but less than 3. Remember, it's a greater than that we have there. So your signs, they will remain as they are. There is no equal to there. It is not there. It is not there. If it was there on your question, you're going to put it on your answer, but it's not there. So that is the case, guys, of our solution. So you can also use your number line. Remember your number line, you have to test your values. This is 2, this is 3. So we need a condition where we are saying when we substitute the values of x, we are going to have what? A positive. Where is it that our answer is going to be what? Positive. Is it for the values that are less than what? 2? Is it for the values in between 2 and 3? Is it for the values that are greater than what? 3. We test the values that are less than 2. You're going to see this one was going to reject, was going to give us a negative. This one was going to reject again negative. Your answer was going to be here between 2 and 3. So between 2 and 3, how can you test, guys, for the values? Since we can see these are whole numbers, we can use decimals. As long we get a positive value, that is what is important. Whether it's a decimal or what. So you can test using any decimal, 2,1, 2,2, 2,3, 2,4, and anyone between 2 and what? Between 2, in between these. So you are going to see that this is the only part where your answer was going to be what? Positive. So I want you to prove that one, guys. This is revision. So let's prove also and see if we are in the right direction. So that was it. 1.2, solve for x and y simultaneously. So let's see. We have a quadratic and another one is linear. Remember I said in this case, simply work with the linear. Make either x or y the subject, whatever that is easy for you to make the subject, substitute into the what? Into the quadratic. So in our case, it is, okay, let's say equation 1, equation 2. It is easier for us to work from here, make y the subject. Here we can simply, sorry for that. We can simply transpose and make y the subject here on our case. Okay, here, this one, it is easier to make this y the subject because we need to take the x to the other side and also the 2 there to the other side. So that's 1.2. So from equation 1, all right, this is equation 1. This is my equation 2. Do not worry. So from equation 2, make y the subject. It is easier for me to make y the subject. So I'm going to take the x to the other side, the minus 2 to the other side. So it means y is equal to 3x. You take it to the other side. So it will be what? Negative 3x. It was a positive. 2 to the other side is going to be what? A positive. It was negative 2, so it will be positive 2. So this is the y that we have. We can call this equation 3. So what is it that you're going to do? You substitute this in place of y of the equation 1. Not here where you made the subject, but in the other equation. Remember I said in the other equation. So you are going to substitute, that's equation 3, this one, into equation 1. Into equation 1. So into equation 1, in place of y, remember, in place of y. So that will be x squared minus 2x times y. There is a y there. There is a y here. So in place of that y, we substitute this, which is our x. So this is minus 3x plus what? Plus 2. Minus 3y squared. So that's minus 3y is equal to the whole of this. So you open a bracket again, minus 3x plus 2. But this is what? Y squared. So it must be squared. Is equal to 0. We have formed an equation, guys, with the x only. So expand the bracket, simplify, and see what you're going to have at the end, guys. Let's try and see x squared here. There is a bracket. So distribute, guys, by what? Negative 2x. So it's going to be negative 2x outside of the bracket times this, which is positive 6x squared, negative 2x, and this, that's negative 4x. Okay. Moving on to this, we can expand first this one and then use the minus 3, which is outside. So it's minus 3 into whatever that you're going to have. So guys, we can use those expansion of brackets, the a minus b squared concept, by rearranging this into 2 minus 3x like that. Or you can just expand, guys, 2 brackets. It's up to you guys. You just make your 2 brackets. This is what? Minus 3x plus 2. It means we're going to multiply to another bracket of minus 3x plus 2. It's up to you. So expand minus 3x and minus 3x, that's positive. 9x squared minus 3x, minus 3x and 2, minus 6x, 2 and minus 3, minus 6x, 2 and 2, that's a 4. So collecting these like terms, you're done. So it was going to be positive 9x squared minus 6 minus 6, that's minus 12. So you're going to have minus 12x plus what? Plus 4. All right, just like that. It is equal to 0. So these can be expanded using identities. It can be expanded using normal expansion of brackets the way that you are used to, guys. So this is where you are. Okay, let's expand this part. Also here, collecting like terms, we have got like terms. So let's also just collect like terms as we are expanding the brackets. Let's also consider the like terms at the same time, because we've got a bracket here, which is fine. But at the same time, there is what? There are like terms there. So this is it here, guys. All right. Up to here. So expanding this, it was going to be what? Let's see. This is 1 plus 1 here. The 1 plus 6. That's 7x squared minus 4x minus 4x this one. All right. So that's minus 4x. Then on this bracket, it is the minus 3, which is in contact with the bracket, this one. It is the minus 3. So the minus 3 is the one that is expanding every term, negative 3 times 9, which is going to be negative 27 x squared. We do the same thing, negative 3 and negative 12, that will be positive 36x. The same thing, negative 3 and positive 4, that's negative 12. That's equal to 0. All right, so this is where we are. We can collect the like terms again, the part of x squared and the x squared. So that's 7 minus 27. 7 minus 27, which is what? Negative 20. So that's negative 20x squared. The same thing, negative 4 plus 36. That's 36 minus 4, which is what? 32. Positive 32x. Okay. Then the minus 12 and it's on like that. Minus 12 is equal to 0. Do we have anything common in this equation of ours? We can reduce this equation. As we can see, we can even choose to reduce by 4. But we can choose negative 4 because this is negative 20. So to make it a positive, let's use negative 4 here, negative 4 here, negative 4. Just try to reduce your equation. Even if you are to use the quadratic formula, just try to reduce. So negative 20 by negative 4, that's 5x squared. 32 divided by negative 4, that's negative 8x. Minus here, that's a positive 12 divided by 4, which is 3. That's equal to 0. So there we can use our factorization. We've got factors. Yes, you can use the quadratic formula. You can also use the factorization. So I want you to prove with the quadratic formula. But as for me, I'm going to use the factorization. The one that is most complicated to you is the one that I'm going to choose, guys. Most of you do not want to see this factorization. You just keep it away. But for those who'll be using factorization methods, so this is what you're going to need. 5x squared minus 8x plus 3. As we can see that the coefficient of x squared is not 1, it is a 5. So we can choose to get rid of this 5, okay? I explained that different ways. So using the cheat method, I said you can take the 5, multiply it to the other term there, multiply by 5. So meaning to say we no longer have that 5. So it will be x squared minus 8x plus 3 times 5, which is 15. So as we have 15, we can consider the factors of 15, which add up to what? Negative 8, since the coefficient of x squared is now a 1. So that is the case. So it's simply going to have two brackets, x here, x here. So factors of 15, adding up to negative 8, we've got 5 and 3. So let's just have negative here. So you're going to have negative 5, negative 3. Then we bring back the 5, this one that we lost before, the one that we store here, we have to bring it back. Where we see the x, we put back the 5. Where we see the x, we put back the 5. Is there any bracket where we've got a common term? All right, the first bracket, 5 is common, so we can factor out that 5. Factoring out this 5 is going to give us what? X minus 1. This one is not affected. So if you are using this method, guys, you can see that the 5 is outside. I said you get rid of that. It is no longer part of your question. So these are the two brackets that you need here. So using any method, guys, that you are capable of, or anyone, guys. So you can even start with this bracket into this bracket. It's one and the same. This bracket, you can start with this one. It's one and the same. To have these brackets, guys, so many applications, so many ways, factorization, so many different techniques and shortcuts which can be used. So use anyway. But for those who are using the quadratic formula, there are no ways. Guys, just use your quadratic formula. Everything will be direct. So x will be equal to what? Minus 1 to the other side. That's positive 1, or x is equal to, you were going to take the negative 3 to the other side. So it was going to be 5x is equal to 3. Then definitely divide by what? By 5. So x is equal to what? 3 over 5. So these are the conditions of the x that we are going to have from this equation. All right, this was 5x minus 3 or 5x minus 1. All right. Where are my brackets? All right, I have erased those brackets, guys. Now I cannot tell. Was it 5x? Was 5x minus 1. All right, let's see. This is 5x squared minus 3x minus 5x minus 3. All right, plus 3. Like this. So it's gonna be negative. All right. 5x squared minus 8x squared plus 3. Okay, this is it. So that is exactly what we're going to have there. So with the values of x that we are going to have, all right, I'm just like into this bracket, like the first one, guys. Let me go back to that part, because here, guys, I'm just like, I erased something that I needed to see before, and now I need it. So anyways, let's see. We say this is what, 15. So it was x squared minus 8x plus 15. Then 15, we got negative. It was negative 5 and negative 3. Remember, x minus 5, x minus 3. Oh, it was minus 3. All right, then a 5 here. So it was x minus 3. I see, guys. To say no. The way that I wrote, I'm writing something else there instead of what I had. This was what, 5 here. Sorry for that, guys. You see, guys, this was 5 and this was x minus what? X minus 3 here. So we have the 5 here. So it's 5x minus 3. So it's x minus 1, 5x minus 3. 5x minus 3, x minus 1. All right, 5x minus 3, x minus 1. This is exactly what we had. Okay, so we are in the right direction. X minus 1 and what? 5x minus 3. Okay, no problem. So it is actually the other way, which is your guys. You see, when you are using these memos, guys, they add something like this. Let me bring it so that we just correct while least we move on, guys. There's something like this: 5x minus 1 into x minus 3. If you are to expand this, let's say 5x and 5x, it was going to be 5x squared, 5x and this minus 15x. You see, 5 and this, it was going to be minus 15x. Minus 1 and this, it was going to be what? Minus x. Minus 1, it was going to be positive 3. This was going to be negative 16x, not negative 8. So, guys, if you are also working with your memo, guys, be very careful, because here I was like, let me check what is happening. I'm seeing they're writing answers which are totally away from what you're supposed to get. Anyways, guys, this is what we have. Let's substitute. Where is our y? There is our y, which is the subject here. We substitute back our x there. Y is equal to minus 3x plus 2. So remember that y is equal to minus 3x plus what? Plus 2. So substituting the value of x, which is 1. Let's see what we're going to have here in place of what? In place of x, when x is 1. So that's y is equal to minus 3 into x, which is 1, plus 2. So y is equal to minus 3 plus 2, which is negative 1. All right, on the condition that x is 3 over 2, y was going to be minus 3, 3 over 5, this one. It was going to be 3 over 5 plus 2. So y is equal to, there we can simply use our calculator. So let me bring my calculator here. I did not prepare this one, guys. So I'm just going to bring my calculator here. So this is it. I want to go back to the normal mode. So that is it. Negative 3 into 3 over 5 into 3 over 5 like this, plus 2. So that's 1 over 5. So y is equal to what? 1 over 5. All right, this is the part of y there. So y was going to give us what? 1 over 5. And our x being 3 over 5 at that manner. So that is it. I want you to go through, revise, and see if we're on the same page, guys. If you're on the same page, and also, guys, you see your memos, sometimes they just do some more. But just try to work out, guys, more questions. The more questions that you do, the more you see, okay, this is supposed to be like this. And like I said, here, you can use the quadratic formula. So you can even prove this one with the quadratic formula. So I want those who are using the quadratic formula to see if we are having the same values there of x. All right, you must have the same values for your quadratic formula. All right, on question number 2, solve this one. Okay, simplify. This one is to simplify 4 marks. Let's figure out what is it that they needed us to do here. 2.1, 10 to the exponent of n plus 3 times 5 to the exponent of n minus 1 over what? 50 to the exponent of n plus 2. All right, so if we are to consider here, we have got something common, the 10, the 5. It is also here in this 50. Yes, you can have your answers, guys, in simplest form to say 10 in simplest form. 10 is 2 times what? 5. 50 you write as a product of its prime factors. But guys, also we can see that the 10 that we have here, this 10 here, and this 5 that we see here, they are there in this number 50 here. We have the 10 and the 50. Remember, 5 times 10 or 10 times 5. So we can split that. There's no need, guys. There was no need for us to even write the smaller numbers. Let's use them as they are. 50 in terms of what? 10 and what? And 5 is 10 times what? 10 times 5 or 10 times 5. Like that. So that's 10 times 5 to the exponent of what? N plus 1. So remembering to the exponent of n plus 2, sorry. Remembering your exponents that if you are given ab to the exponent of n, that's a to the exponent of n, times this b also raised to the exponent of n, meaning to say everything will be affected by the given exponent. Everything must be affected. So in our case, 10 must be raised to the exponent of n plus 2. 5 also must be raised to the exponent of n plus 2. So you're going to have something like this. 10 to the exponent of n plus 3 times 5 to the exponent of n minus 1 over what? 10 is raised to this exponent. So that's 10 to the exponent of n plus 2. 5 also. So that's 5 to the exponent of n plus 2. Now we are back, guys. When the bases are the same in the base of 10, here we've got the base of 5. X to the exponent of a, or x to the exponent of m, over x to the exponent of n. We are dividing. You subtract the exponents. So in this case, we are going to subtract. So that is 10. This exponent of n plus 3 is going to subtract this one as it is, which is n plus 2, times, you move on to the 5. This is to the exponent of n minus 1. We subtract this other exponent, which is n plus 2, like this. Take note, guys. The 10 on its own, the 5 on its own. So that was it. So expanding these brackets so that we can simplify, that's 10 to the exponent of n plus 2, n plus 3, minus times n, that's minus n, minus times 2, minus 2. Okay, the part of our 5, n minus 1, let's multiply. This is negative 1. Negative 1 times n, negative n, negative 1 times 2, negative 2. So we can see that the n and the n here was going to cancel. All right, in our numbers, guys, this is same as we've got 1n and 1n. So n minus n, that's a 0. 3 minus 2, that's 1. So that's 10 to the exponent of 1 times the same thing, n minus n cancels. You remain with minus 1, minus 2, which is what? Which is minus 3. Okay? So remember, guys, if a number carries a negative, x to the exponent of minus n, that's 1 over x to the exponent of n. So this was going to be what? 10. Any number to the exponent of 1 remains as it is, times what? 1 over 5 to the exponent of 3, which is 125. So that's 10 times 1 over 125, 5 to the exponent of 3. 10, guys, is same as 10 over 1. So we multiply the numerators together. 10 times 1, which is 10 over 1 times 125, which is what? 125. So we can even reduce, guys. Okay, we can even reduce this 125. 10 over 125. This can be reduced by 5. Okay, by 5 here. That's a 2. 5 here. That's 2 into 10. Remember 1 here. That's gonna be 5 into this. That's remainder 2 into 12. Then into 25. That's a 5. So that will be 2 over 25. So we could have reduced the numbers before. Like I said, we could have reduced the numbers here before, okay, on the original question. But because we saw 10 and 5, they are factors of what? Of 50. So you can work with these numbers as they are. Then you reduce your final answer at the end. So this is how these questions are given. Just make sure that you work with more questions, as many questions as you can. It is in your hands. So let's simplify in as much as we can. That's it, guys. Till we meet again.